In the last lecture, we have discussed the curl, divergence, and the formula for a directional derivative. Okay, now let us try to solve the problem based on directional derivative. Okay, I hope you are able to see this journal. Yeah.
Yes, sir.
Okay, that's great. Okay. So we go with the example. Find the directional derivative of y is equal to x raised to 4 plus y raised to 4 plus z raised to 4 at a 1 minus 2 1 in the direction of AB, where B is 2 6 minus 1. Okay, so that's what we have. Now we have to find the directional derivative. So here we have point A, that is 1 minus 2 1, and we have point B, that is 2 6 minus 1, and we have to find the directional derivative in this direction. And what we have given a function, scalar function phi. Okay, so that's what we have. Okay, now if we want to have the directional derivative in this direction, okay, what is the formula? So we have formula del phi into a bar upon mod of a bar. Okay, so what this a bar is? This a bar is the vector AB. So what is the vector AB, or how we are able to get the equation or the representation of this vector AB? So this is OB bar minus OA bar. Okay, so this is how we are able to get the vector AB bar, which is going to be A bar. Okay, now this we have to calculate, and then we have to calculate what is del phi. Okay, so we'll calculate del phi, and then we'll consider the direction, okay, to the del phi. So this is the precisely dot product of two vectors. So here del phi will be also a vector, and a bar upon mod of a bar will be also a vector. So if I consider dot product, we have already defined dot product. This will give us the directional derivative of phi in the direction of this vector a bar, AB bar, AB or A bar. Okay. So let us try to have the solution. Let us try to write the solution for this. Okay. So we need to have this AB. Okay. Now what we have, let phi is equal to x raised to 4 plus y raised to 4 plus z raised to 4 be the scalar function. It's going to be the scalar function. Okay. Now we have the point A. We have to consider this at point A. So we have A is equal to 1 minus 2 1, and we have the point B is equal to 2 6 minus 1. Okay, so what we'll do is consider A bar is equal to AB. So what this AB is, this is OB. The coordinates of B are given, that means it is the vector OB minus OA. So if I represent this A, then it is going to be 1I minus 2J plus 1K. And if I represent this B, then it is going to be 2I plus 6J minus 1K. Okay, so that's what we have. Now, this is equal to what you'll be having here, 2I minus, this is going to be plus 6J minus K minus, what is the term you'll be having here? I minus 2J plus K. So if we simplify this, what do you have A bar? So this is 2I minus I plus this is 6J minus minus plus 2J plus this is minus K and this is again minus K. So what we get here, this is I plus 8J and minus 2K. So we got here A bar is equal to, okay, so what is the value of A bar we got here? This is I plus 8J and minus 2K. Are you getting this vector A bar?
Yes, sir.
Okay. So now we got this vector A bar, and then what we have to do is we have to find its modulus. Okay, so let us consider its modulus. So we have mod of A bar is equal to square root of 1 square plus 8 square plus minus 2 square. Okay, so what this term is going to be? This is 1 plus 64 plus 4. So what do you get this one? Is that okay?
269. Yes, sir.
Yes, sir.
Correct. So 69 is not a perfect square, so let it be as it is. Okay, so if it is a perfect square, we'll take it out. If it is not, then let it be as it is. Okay. Now we got A bar, we got mod of A bar. What is the next term we need to calculate is del phi. Okay. So consider what is the operator del? Del is I double by double x plus j double by double y plus k double by double z. So we have del phi equal to I double phi by double x j double phi by double y plus k double phi by double z. Now we know the value of phi. So what is phi? X raised to 4 plus y raised to 4 plus z raised to 4. So what these values will be? So we get here del phi is equal to I double by double x of x raised to 4 plus y raised to 4 plus z raised to 4 plus j double by double y of x raised to 4 y raised to 4 plus z raised to 4 and plus k times double by double z of x raised to 4 y raised to 4 plus z raised to 4. Now see this, what we get here, del phi is equal to, so what will be the derivative of this with respect to x?
4x cube.
4x cube.
It is going to be 4x cube I plus 4y cube j plus 4z cube k. Are you able to get this? Because here y raised to 4 and z raised to 4 are going to be constant, so derivative is going to be 0. So here x raised to 4 and z raised to 4 are going to be constant, so the derivative is going to be 0. And in this term, here x raised to 4 and y raised to 4 are going to be constant, so derivative is going to be 0. These are the terms that we have. And now we have to calculate this directional derivative at A. So we have to calculate the value of this function del phi, the vector, at A. Okay, so what we can have here, hence at A what is the point? We have A. So A is 1 minus 2, 1. So A is 1 minus 2, 1. Okay, so that means X is going to be 1, Y is going to be minus 2, and Z is going to be 1. Okay, so we have, what will be having here? Del phi at A is equal to. So what is del phi at A? See, it is going to be 4 into 1 cube I plus 4 into minus 2 cube J and plus 4 into 1 cube K. So we get del phi at A is equal to, this is 4I. What this term will be?
32J.
Minus 32J. Okay, because minus 2 cube is going to be minus 8.
4K.
Okay, and this is going to be plus 4K.
4K.
Okay, so we got the value of del phi at A. And now we have to consider the directional derivative. Okay, so we write here the directional derivative of phi at A in the direction of AB is given as. So what is the derivative? Del phi dot A bar upon, you can have mod of A bar. So we have 4I minus 32J plus 4K dot, what is A bar we have calculated? So here we have A bar I plus 8J minus 2K. Okay, so it is going to be I plus 8J minus 2K. And here, this is divided by root of 16. So is that okay? Are you getting this step? Are you getting this step?
Yes, sir.
So what we have here, this is equal to. Now the dot product of these two. So what is the dot product of A1I plus A2J plus A3K into, this is the dot product B1I plus B2J plus B3K. This is A1 B1 plus A2 B2 plus A3 B3. Okay, this is the dot product. So I have it here. So this will be 4 plus, this is minus 32 into 8 plus, this is 4 into minus 2. And here we have root of 69. Okay, so that's what we get here. Now calculate. Okay, so this is going to be 4. What this term is going to be?
Minus 256.
Minus 256.
Minus 256. And what this term is going to be?
Minus 8.
Minus 8.
Minus 8.
Okay, upon this root of 69. So what the numerator will be?
Minus 260.
Minus 260 by, here will be having root of 69. So what we got? We got the directional derivative of phi is, what do you got here? Minus 260 by 69. So is there any doubt?
Sir, it should be root 69.
Root of 69. Okay, so all of you got this example?
Yes, sir.
Yes, sir.
Is there any doubt in this example?
No, sir.
No,
No,
sir.
Okay, good. all of you are done with this example.
Yes, sir.
So let us try some another example. Okay. Find the directional derivative. I is equal to xy square plus yz cube at a is equal to 2 minus 1 1 in the direction of the vector I plus 2j plus 2k. So we go with the solution. Now here this vector a bar is already given. Okay, so we don't have to find a bar. In the last case, we have to find a bar. So here already the vector a bar is given. So we can directly find del phi at this point and the dot product with this. Okay, so we go with the solution. Let y is equal to xy square plus yz cube be the scalar function and we have a is equal to. So what is the point given? 2 minus 1, 1. Okay. Now consider the vector a bar is given. So it is I plus 2j plus 2k. And hence mod of a bar is equal to square root of 1 square plus 2 square plus 2 square. So what this value is going to be? 1 plus 4 plus 4. So we got here mod of a bar is equal to, what is the value of mod of a bar? Root of 9. So it is going to be 3. Okay, so we got here mod of a bar is equal to 3. Now what we have to do is we have to consider this gradient of this function phi at the given point A. So let us calculate the gradient. Okay, hence we have L is equal to I double by double x j double by double y plus k double by double z, and hence consider del phi is equal to, we will be having del phi I double phi by double x plus j double phi by double y plus k double phi by double z. So this is equal to I double by double x of xy square plus yz cube plus j double by double y of xy square plus yz cube plus k double by double z of here xy square plus yz cube. Now let us simplify this. So we get I is equal, this del phi is equal to I, and here we are finding the derivative with respect to x. So other terms will be treated as a constant. So this will be I y square plus j. Here we are finding the derivative with respect to y. So you will be having 2xy plus z cube plus, here you are finding the derivative with respect to z. So it will be 3z square y. So are you getting this term? Is that okay? Are you getting these derivatives?
Yes, sir.
Okay. So we got del phi is equal to y square I plus 2xy plus z cube j plus 3yz square k. Now at a is equal to, so what is the point a given? 2 minus 1, 1. Okay, so it is given 2 minus 1, 1. So here what we know, the value of x is 2, the value of y is minus 1, and the value of z is 1. So we have, what we have, del phi at a is equal to, okay, so what will be the value here? This will be minus 1 square I plus, this is 2 into minus 1 plus 1 cube j, and plus, what will be having here? 3 into minus 1 into 1 square k. So this is del phi at a equal to, so are you getting this I? What the value will be here? See, it will be minus 4 and plus 1. So is it minus 3j?
Yes.
Are you getting this?
Yes,
And
sir.
this term, what this term will be?
Minus 3k.
Correct? So we got del phi. We know the vector and its modulus. We are able to find the directional derivative. So we write here, hence, the directional derivative of phi in the direction of given vector P, we have taken it as a bar. Given vector a bar is given as. So what will be having? This is equal to del phi dot a bar upon mod of a bar. So it is I minus 3j minus 3k dot. What is the vector given? It is going to be I plus 2j plus 2k. So it is I plus 2j plus 2k. Okay, and we know the modulus, that is going to be 3. So this is equal to, what you have? 1 into 1 plus minus 3 into 2 plus minus 3 into 2. Are you getting this dot product? Are you getting this dot product?
Yes, sir.
Yes, sir.
Okay, so what we are able to get here, this will
Minus
be
7.
1. Okay, this will be 1 minus 6 by 3. So is it minus 11 by 3?
Yes, sir.
Yes.
What we got here? The directional derivative of phi is minus 11 by 3. Got it? Is there any doubt in this example?
No, sir.
Okay. Got this one?
Yes, sir.
Okay. So let us try to go for the another example. Okay. So before going to the next example, I want to give you a note or a remark. So what we know is, if y is equal to y of xyz is a surface, is a scalar surface, then del phi is perpendicular or normal to the surface phi. Okay, so what we have here, if phi is a scalar surface, then del phi is perpendicular or normal to the given surface. Okay, and when we say two vectors are perpendicular to each other,
Their cross product is 0.
cross product is 0 or dot product is 0.
So
Dot
dot
product.
product.
Dot product should be 0.
Yeah. So if two vectors are perpendicular, then their dot product is 0. Okay. So we have to consider the dot product. Okay. So let us try an example. Okay. Here we have to go with find the constants A and B such that the surface ax square minus byz equal to a plus 2x will be orthogonal to the surface or x square y plus z cube equal to 4 at 1 minus 1. Okay, so this is the question that we need to understand and answer. Okay, so here what is given? We have two surfaces given. So first surface we'll consider phi 1, other surface we'll consider phi 2. Okay. Now we have to find the value of these constants A and B such that these two surfaces are orthogonal at the given point. Okay, these two surfaces are orthogonal at the given point. What it means? The angle of intersection of the tangents of these two surfaces at this point is going to be 90 degrees. Or in other words, if I say that two tangents are going to be orthogonal at this point or intersecting each other in the 90 degree, that means their dot product is going to be 0. Okay, so that means their dot product is going to be 0. So we have to use this information and then we have to find the values of A and B. So first of all, we need to find what are the tangents or what are the normals to the surfaces. Okay, and we know if phi is going to be the surface, then del phi is going to be the perpendicular, or it is a tangent, or it is a normal, or it is orthogonal to the given surface. Okay, so we have to find the del of both of these surfaces, and then we have to find the value of del at this given point, and we have to consider the dot product equal to 0, and then we are able to get the value of A and B. So this is what we have to do in this example. Okay, so let us try to solve the example. So let phi 1 equal to, so this is a surface. I'll write this as ax square minus byz minus a plus 2x is equal to 0. So is that okay? Are you getting this equation?
Yes, sir.
Okay, what I did is I have taken this term on the other hand side. Okay, this is equation 1. And y2 is equal to 4x square y plus z cube minus 4 is equal to 0. This is equation 2. Are you able to get this equation? Are you getting this equation?
Yes,
So what
sir.
I did here, I
Yes,
have taken this 4 on the other hand side. Okay, so I write here B the surfaces. Okay. Then write A equal to 1 minus 1 2 B point. Okay. So we have del phi 1 is equal to I double phi 1 by double x plus j double phi 1 by double y plus k double phi 1 by double z. Okay, that's what we have. Now let us find this derivatives. So we'll be having I into the derivative of this term with respect to x. So it is 2ax minus a plus 2. Is that okay? Are you getting this?
Yes, sir.
Plus j. We are finding the derivative of this with respect to y now. So it is minus bz. And plus k. We are finding the derivative with respect to z. So it is going to be minus dy. So what we get here, del phi 1 equal to, so 2ax minus a minus 2 I minus bzj minus byk. This is equation 3. Okay, or we have to consider at this point. Okay. So we got here, yeah. Okay. This is going to be the function. Now, what we got here? See, at A. So A is a point 1 minus 1, 2. We have,
Excuse me, sir.
yes,
Sir, will there be k into 3z square?
mm, we are considering this function. We are not considering the phi 2. We are considering phi 1 yet.
Yes, yes, sir. I can.
Okay.
Sir, can I ask you something?
Yes, yes.
Actually, sir, before proceeding further, sir, can you please explain me the statement which you wrote here? Surface, yeah,
This one.
that's one. Phi is if y is, yes.
Yes, yeah. Okay. So as we know about the first order derivative of any function, suppose we consider the function of one variable. Okay. Then how do we interpret the first order derivative? We interpret the first order derivative as a tangent, right? Are you
Yes,
getting
sir.
this? Okay, we
Yes, sir.
interpret the first order derivative as a tangent, right? Okay, this is now more than one dimension case. Okay, so when you have only x, it is going to be one dimensional case. This is more than one dimensional case. So here we have a scalar surface. Okay, and if I consider all the such first order derivatives in all direction, then it forms the tangential surface to this surface. Okay,
Okay, sir. Means
so
phi is any scalar surface And
Yes.
if we find del phi, then it is a tangential surface to the surface,
Yes.
scalar surface.
Yes, exactly,
Okay.
exactly. Okay, got it? Okay.
Yes, sir. And which surface is perpendicular to scalar surface, sir? The tangential
So,
one, right, sir?
yeah, this is the tangential one, no?
Okay,
Yes.
sir. And del phi at A means at point A.
At point A, yes, we are calculating
sir.
at particular point A.
Okay, sir. Thank you.
Yes, welcome. So here we are calculating this del phi at A now. Okay, so here at this point we have the value of x, we have the value of y, and we have the value of z. Again, so let us put this value. What we'll have here, so this term is going to be, x is going to be 1. So this is 2a minus 2i. Then minus p, z is going to be 2. Okay, j. And minus p, y is going to be minus 1k. Okay, so actually we get here this del phi 1 at a, this is equal to, so what we got here, this is a minus 2i minus 2bj and minus minus plus, this is going to be bk. Okay, so we have used equation 1, equation 2, and that's why this is going to be equation 3. Okay, now consider del phi 2. So it is I double phi 2 by double x plus j double phi 2 by double y plus k double phi 2 by double z. Okay, and now we have to use this equation 4x square y plus z cube minus 4. Okay, so here what we get here, I double by double x of 4x square y plus z cube minus 4. Okay, so we can see this here 4x square y plus z cube minus 4. Now we get here plus j double by double y of 4x square y plus z cube minus 4 plus k double by double z of 4x square y plus z cube minus 4. So let us find the derivative with respect to x. So what will be the derivative with respect to x? Is it x, y, I? Because the derivative of these two terms is going to be 0. Okay, so we have to consider the derivative of this term only. And here x square, the derivative of x square is going to be 2x. So we get here 8xyi. So is that okay? Are you getting this term?
Yes, sir.
Plus. Okay, so here we'll be having 4x square j. Is that okay?
Yes, sir.
Okay, so this is 4x square j because we have the derivative of y is going to be 1. And plus the derivative here, so it is going to be 3z square k. Is that okay? Are you getting this derivative?
Yes, sir.
Okay. So now at a. Okay, so we have to consider at a. Again, it is 1 minus 1, 2. So at a, 1 minus 1, 2. We have. Okay. What we'll get here? T. This will be del phi 2 at a is equal to 8 x y I plus 4 x square j plus 3 z square k. And hence what we get here, del phi 2 at a is equal to, so it is going to be minus 8i plus 4j and plus this will be 12k. Is that okay?
Yes, sir.
Are
Yes,
you
sir.
getting this now?
Yes, sir.
Yes. Okay. So this will be our equation 4. Okay, because we have this equation 3. Del phi 1 at A is equation 3. So what will happen? Del phi 2 at A is going to be 4. Now, what we know is, since phi 1 and phi 2 are orthogonal. Orthogonal means they are going to be perpendicular. Okay. Hence, what we can say is del phi 1 and del phi 2 will be orthogonal. That is, what we know is del phi 1 dot del phi 2 is equal to 0. So let us have this del phi 1. So what is del phi 1? Here we got a minus 2 minus 2b plus b. Okay, so here where we have a minus 2I minus, we got here 2bj. So this is 2bj. Then what we got here? Plus bk. Okay, plus bk. Dot, what we got here? This is minus 8I plus 4j plus 12k. That is going to be 0. Okay, so now have the dot product. A minus 2 into minus 8 plus minus 2b into 4 plus b into 12, and this is going to be 0. Let us simplify. So this is minus 8a plus 16 plus, what you'll be having, this is going to be 12b and it is going to be minus 8b. Okay. So this is equal to 0. Okay. What we get here, the sum. So we have, this is 16 minus 8a plus this term. Okay, so 4b is equal to 0. Are you getting this?
Yes, sir.
Okay. So we got this. Okay. Now, this is one equation where we'll get the relation between A and B. So what I can write is here, is it 16 minus 8A plus 4B is equal to 0. So can we write this as, we can cancel 4, right? Out of all these constants, we can cancel 4 and we can write this as 2A minus B. I am taking this on the other hand side. Okay, so if I cancel 4, what I'll get is 4 minus 2A plus B equal to 0. So I can write this as, what we'll be having here, this is 2A minus B equal to
Is
4.
equal to 4.
Yes, this is the next equation. We can say what this equation is going to be 5. Okay, we got now 2 unknowns and 1 equation. Okay, so if we want to have the value of these 2 unknowns, I must have 2 equations. Okay, but one more thing that we have is point A. Okay, the given point A is on this surface. This point A is on this surface. That's why if I consider the value of phi 1 at A. Okay, because A point is on phi 1 also. Okay, so we can use the value of A and phi 1. So we write here, since the point A is on the surface phi 1, we have, okay, what we'll be having here. So see the equation of this surface. Okay, so phi 1 is equal to ax square, okay, minus byz minus a plus 2x equal to 0. And A is a point. What is this point? 1 minus 1, 2. Okay, so we can write here, at A, we have A is going to be A1 square. Okay, now minus B, y is minus 1, z is 2, minus A plus 2, and this is going to be 1 is equal to 0. Are you getting this equation?
Yes, sir.
This equation? Yeah. Okay. If we simplify, what we get here, this is going to be A. This term is going to be plus 2B. This term is minus A and minus 2. Okay, is equal to 0. So I can write this as, is it A minus A is equal to 0? And 2B is equal to 2? Are you getting this? Because this is A, this minus A, it will be 0. 2B is equal to 2. Are you getting this equation?
Yes, sir.
Yes, sir.
Yes, sir.
Can we
Yes.
write B is equal to 1?
Yes, sir.
Okay, we can write B is equal to 1, right? Okay, so we use here using the value of B in equation 5. We get. Okay, so what we are able to get here? See, this is 2A minus B is equal to 4. So 2A minus 1 equal to 4. So I can write 2A is equal to 5, and hence A is equal to 5 by 2. Is that okay?
Yes, sir.
Yes, sir.
Okay, that's what we can have. Okay, so we got the value of A, we got the value of B, and with these values of A and B, the scalar surfaces phi 1 and phi 2 will be perpendicular to each other at the given point.
Excuse me, sir.
Yes,
Sir, sir, we reached up to equation number 5. 2A minus B is equal to 4, sir.
yes,
Right?
yes,
And sir, if we take B is equal to 4 minus 2A and we put the
yes.
value of B in it, so can we find the answer by it also?
If we consider B is equal to
4 minus 2A.
4 minus 2A, no, 2A minus 4 it will be, no?
Means minus B is equal to 4 minus 2A.
Okay, minus B is equal to 4 minus 2A. Okay, correct.
So 2A and 2A minus 4 minus 2A, right, sir?
Yeah,
So we can find, sir, and that's why, sir, I got values A is equal to 1 and B is equal to minus 2.
okay.
So I just want to ask that is it right if we do that way also?
See, we need to check. Okay. So I hope all of you got this example. Let us go for some more examples. Okay. Is there any doubt in this example?
No, sir.
Okay. And let's go for another example. If the bar is equal to x plus EYI plus y minus 2z j plus az plus x a is solenoidal, then find the value of. Okay. So we have a vector given that this vector function is going to be solenoidal. So when we say a vector function is going to be solenoidal, can we say a
When
vector?
divergence of f bar is 0.
Correct. So when we say if the divergence of f bar is going to be 0. Okay. So what we have to use? We have to use the condition that del dot f bar is going to be 0. Okay. And if this condition is satisfied, then we say it is solenoidal. And here it is given that it is solenoidal. So that means this condition is satisfied. And hence, using this condition, we have to find the value of A. So we go with the solution. We have let f bar is equal to x plus so here what we have x plus dy I plus y minus 2z j plus az plus x a be the solenoidal vector. Hence, we have again what we have del dot f bar is equal to 0. So what we get here, del dot f bar equal to 0. So what is del dot f bar? So it is dabba by dabba x of x plus 3y plus dabba by dabba y of y minus 2z plus dabba by dabba z of az plus x, and this is going to be 0. Okay, so let us find the derivative of this with respect to x. So what will be the derivative of this with respect to x? Is it 1?
1. 1.
1.
This is going to be 1. And what this is going to be? A. So this is going to be 0. So we got here 2 plus A is equal to 0. And hence what we got here? A is equal to minus 2. Okay, so if this given vector is solenoidal, then what we have, the value of A is going to be minus 2. So is there any doubt in this example? Is there any doubt?
Yes, sir.
No.
No, sir.
Okay, that's good. So let us go with another example. Find the values of A, B, and C if f bar is equal to AXY plus BZ cube I plus 3x square minus CZ j plus 3x z square minus yk is irrotational. Okay. So this is irrotational. Okay. So we are given that this vector is going to be irrotational, and then we want to find the value of this ABC. So what is meant by irrotational?
Curl is 0. Curl is 0.
Curl is 0. Okay, so what we'll be having? This is del cross f bar is equal to 0. Okay, what we get here? Del cross f bar is equal to 0. Okay, so let us go with the solution. Okay, what we'll be having here? Let f bar is equal to, so it is given that axy plus bz cube I plus 3x square minus czj plus 3x z square minus yk be the irrotational vector. It's going to be irrotational vector, and hence we have del cross f bar is equal to 0. So what we have, this is mod of I j k dabba by dabba x dabba by dabba y dabba by dabba z, and here what we know is going to be axy plus bz cube, and here what we have, this is 3x z square minus y. Here what we have, this is 3x square minus cz, and here we have 3x z square minus y, and this has to be 0. Okay, so let us simplify. We have here hence I dabba by dabba y of 3x z square minus y minus dabba by dabba z of 3x square minus cz minus j. Okay, what is the term here you'll be having? Dabba by dabba x of 3x z square minus y minus dabba by dabba z of axy plus bz cube and plus k. This is dabba by dabba x of 3x square minus cz minus dabba by dabba y of axy plus bz cube, and this has to be 0. Are you getting this expansion? Are you getting this expansion?
Yes.
Yes,
Okay.
sir.
Good. So let us simplify this. So we'll be having I. Now we have to find out the derivative with respect to y. So it is going to be minus 1 minus. Here we have to find the derivative with respect to z. So this is minus c minus j. Here we have to find the derivative with respect to x. So it is going to be 3z square minus the derivative with respect to z. So what we got here, this will be 3bz square. Are you getting this derivative? Plus k. Now we have to find the derivative with respect to x. So here we have 6x minus, we have to find the derivative with respect to y. So we'll be having AX. So here we get the derivative with respect to y, and that is going to be AX. And this has to be 0. Okay. Now simplify. So we get here, see, this is -1 and this is C. So C plus 1I minus is going to be 3z square is going to be common. So we can write here 1 minus B, and this is 3z square J and plus. So here we can have X common. So 6 minus A X K, this is equal to 0. So is that okay? Are you getting this one?
-1, no?
Sir, it will be C minus 1.
So it will be C minus 1.
Yes. Okay. So this will be C minus 1, right? Okay. So is there any doubt up to this? Are you getting this one? Okay. So what we can say is, since right hand side is, what is the right hand side?
0 vector.
0 I can. 0 I plus
Is
0.
0 vector. Okay. So this is 0 means it is going to be 0 vector. And if it is 0 vector, so how you are able to write down this? This 0 is nothing but 0I plus 0J plus 0K. So that means this value is going to be 0, this value is going to be 0, this value is going to be 0. Okay. So here what you are able to get, so these are all components are going to be 0. Okay. So all components are going to be 0, means this is going to be 0, this is going to be 0, and this is going to be 0. So we have, what we'll be having here? See, this will be C minus 1 is equal to 0, then 1 minus B is equal to 0, and 6 minus A is equal to 0. So we can write here, hence A is equal to 6, B is equal to 1, and C is also equal to 1. So if I know that the value of this given vector or the property of the given vector, then I'm able to find the missing constants or the terms which are constant. So here the information was given that the function is going to be, this vector is going to be irrotational. So if it is irrotational, we know del cross a bar is equal to 0. So using this information, we calculated the value of A, B, and C. So do you have any doubt up to it? Is there any doubt up to it?
No, sir.
All of you got this one?
Yes, sir.
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Okay. So here we have considered the directional derivatives. Okay. We have considered the curl and divergence. Okay. So will you able to solve more problem based on this?
Yes, sir.
It's good. Okay. Now we need to consider the topic, how we are able to find the maxima and minima of the function. Okay, so what we have, if we consider the function of more than one variable and the function of one variable. Okay, so what happens to the function of one variable and what happens to the function of more than one variable? Suppose we have a function of one variable. Now, how we are able to decide whether the function has maxima or the function has minima, and the important where we have to decide whether it is a maxima or whether it is a minima. Okay, so if we consider the function of one variable case, okay, what we know is, suppose we have a function y is equal to f of x, and we want to find the maxima or minima to this function. Okay, so we want to have the maxima or minima to this function. So let f is equal to f of x. So what we do is we find what is f dash of x, equate them equal to 0 to get again the sad points, okay, stationary values. So stationary values are the points where the function changes its behavior. Okay, and then what we do is we find the f double dash of x. So we find the second order derivative, and then what is the test for the second order derivative? So here we get the point x0. Suppose f double dash at x0 is negative, then the function has maxima at x0. Okay, if the double derivative of this function x, f of x at x0 is greater than 0, then the function has minima at x0. Okay, now what happens if we have more than one variable? So this is the one variable case. What happens if we have more than one variable? So have you got this idea? Do you have any doubt in this idea? This is what we have already studied. Okay, so now let us try to consider the maxima minima in case of two variables. Okay, so what happens if we have the function of two variables? So when we consider the derivative, first order derivative, we have partial derivatives. We don't have the total derivative, so we have partial derivative. Here we have to consider maxima and minima. Okay, so let we have f be the function of x and y, where x and y are going to be the independent variables. So be the function of two independent variables, x and y, where x and y are independent. Okay, so now if we want to find the maxima or minima of this function f, then we have to follow the following steps. Okay, so what will go with the steps to find maxima or minima of f? Okay, so first step, find double f by double x. This is we write as fx, and double f by double y. This is fy. Okay, so once you get fx and fy, then we have to think, find the stationary values by solving double f by double x is equal to 0 and double f by double y is equal to 0. So here what we'll do is we'll get all the pairs. Okay. So the solution of these two equations will be the stationary values. So what we'll do here, collect all such pairs of xy which will satisfy these two equations. Now, third, okay, find r is equal to double square f by double x square. T is equal to double f square by double x double y. And s is equal to. So here we change the slight notation. So this is s. S is equal to double square f by double x double y. And t is equal to double square f by double y square at the stationary value obtained in previous step. Okay. Now next. Okay, so we got the stationary value, we got the first order derivative, we got the second order derivative. Now we have to decide whether it is going to be maxima or it is going to be minima. Okay, so what we have here, if RT minus S square. Okay, so R we have calculated, S we have calculated, T we have calculated. Now we have to decide whether it is going to be maxima or minima. So RT minus S square, if it is less than or equal to 0. Okay, so precisely less than 0. Okay, then the function f has neither maxima nor minima at the given stationary point. Okay, so if RT minus S square is going to be less than 0, then we cannot reach at the conclusion. Okay, next, what we have, if RT minus S square is equal to 0, then the test fails. Okay, so we need to investigate the fourth order derivative. Okay, now if RT minus S square is greater than 0. Okay, so if RT minus S square is greater than 0, okay, then the function f has either maxima or minima at the given stationary point value. Again, so once you are sure that there exists a maxima or minima, then we need to understand whether it is maxima or whether it is minima. Okay, so if it doesn't exist, then we cannot calculate. If it exists, then only we are able to calculate. Okay, so what we have here, if this RT minus S square is greater than 0, then only we can have the maxima or minima. Now we have to decide whether it is maxima or whether it is minima. Okay, so what we'll be having, if R or T. So you can consider this value of R or you can consider this value of T. Okay, is less than 0. Okay, so this R and T will behave in the same way. Okay, they will not R or T. If their sign is different, then we cannot have the maximum or minimum. Okay, so R or T less than 0, then F has maxima at the given point. And what we have to do is calculate maximum value of F. Okay, so calculate maximum value of F.
Sir, both has to be lesser than 0. R and T both.
Both will behave in the same way. So either you can test, okay, value of F, that is F max. Okay. Now, if they are greater than 0, so if R or T greater than 0, then F has minima at the given point. And what we have to do the next, calculate minimum value of F, that is F. Okay. So now here what we tested that the function has maxima or minima. If the function has no maxima, no minima, then we cannot find. And then RT minus S square is going to be 0. Then the test fails. We cannot test. We need to go to fourth order derivative. If RT minus S square is greater than 0, then there is the possibility to having the maxima and minima. So we calculate the maxima and minima. Okay. So in this case, if we are done here, okay, so these are the steps we have to follow. Now, once we get the maximum minimum, we have to stop. Okay, but if there is no maxima, okay, so what we have here, we can write if RT minus S square is less than 0, then the point or stationary value is called saddle point. It's called as saddle point. Okay, so if we are getting the value RT minus S square is going to be less than 0, that means there is no maxima minima. So such point is called as saddle point. So do you have any doubt up to this? Do you have any doubt up to this?
No, sir.
Okay. All of you got these conditions, or all of you got these steps?
Yes, sir.
Yes, sir.
Sir, can you please show that once again?
Yes, surely. Okay. So here what we have to do first, if I want to find out the maximum minimum for any function, what we have to do is we have to find out the first order derivative, equate this first order derivative equal to 0, and then find the values. Okay, one important thing that you need to consider here, you should not cancel the variables. You can cancel the constants. Okay, because x may have the value 0, y may have the value 0. So you should not cancel it. Okay, next we have to collect all such points which will satisfy these two equations. Then we'll calculate the second order derivatives. We name these second order derivatives as R, S, and T. And now we calculate the value of R, S, and T at this each of these stationary values. and then we test every point RT minus S square. Okay, so at every point we'll test RT minus S square. So if RT minus S square is less than 0, then that point is a saddle point. It has neither maximum nor minimum. If RT minus S square is going to be 0, then we need fourth order test. So we stop because this test fails, we declare. Now RT minus S square is greater than 0. Then there is a chance that the function will have maximum or will have minimum. So we need to decide whether it has a maximum or it has a minimum. And hence we consider R or T. So any one of these two you can consider. You can consider R, you can consider T also. Okay, and if it is less than 0, then the function has maximum. If it is greater than 0, then the function has minimum. Okay, so that's what we can have. And then we have to calculate what is the maximum value, what is the minimum value by putting the values of X and Y in the definition of F or in the function. So we are able to get it. So this point where RT minus S square is less than 0 is called a saddle. So is there any doubt up to 8? Yes. So if R is greater than 0, or for example, R and T, these two terms have the different signs, then check what will happen to RT minus S square.
It will be lesser than 0.
It will be always less than 0. Okay. If R and T have the different signs, then RT minus S square will be always less than 0. Got it, Dhruv?
Yes, sir.
Okay. So any other question or any other query? Is there any other question or any other query? All of you got this?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, that's
Yes,
good.
sir.